So, for example, the one on the left is a tendon. Tendon here, here, here. What does it do?
Attaches the muscle to the bone.
Attaches the muscle to the bone. So bones, one of the things that bones do, they act as levers. So when muscle contracts, it's going to pull on the bones. So the tendons are composed of what connective tissue? Because you already learned that one. So it's going to be pulled in one direction only. You want it to be able to be pretty strong so it doesn't get dense, regular connective tissue. So a lot of that collagen fibers running parallel. So you have that is dense, regular connective tissue as well as the ligaments. What do you think the ligaments are doing?
Connection muscle to muscle.
They attach bone to bone. Okay, so ligaments attach bone to bone, tendons attach muscle to bone. So those are also considered part of the skeletal system. We also have joints. We'll be doing joints pretty much as we go along. Every once in a while you'll see in your notes, I'm going to mention what type of joint is. But the joints are the articulations. You'll see it's going to be at the end when we do appendicular skeleton. And there's just a table. These are the ones you need to know. So make sure you know them by functional classification and structural. These are functional classifications. Synarthrotic joints don't move, like the ones in your skull, the sutural bones. Amphiarthrotic joints move just a little bit, like the pubic symphysis is an example of an amphiarthrotic joint. Most of the joints in your body are diarthrotic. They're your synovial joints. So they have a lot more movement, and even amongst them, we have some various amounts of movements and kind of what types of movements that we can do, and that's where we're going to go over like flexion and extension again, circumduction, opposition. Those we're going to look at those. But even amongst these, so we'll have structural classification, but right now I'm just introducing you to functional. So what type of things connect them? Is it cartilage or a fibrous connective tissue?
It's like hyaline.
So we have like cartilaginous joints. This is just functional classification, okay? So cartilages are also associated with joints, and this one's only showing you one of them, hyaline cartilage, but fibrocartilage is also associated with joints. So between the vertebra, remember you learned about the intervertebral discs and what was in there? What was the principal connective tissue? Fibrocartilage. So that's actually one of our amphiarthrotic joints is what we have between each of the vertebra, and that's fibrocartilage. But in the synovial joints, you're going to have these articular cartilages found at the end of the bone. It's hyaline cartilage. Provides a little glassy, smooth surface for these joint formation. But hyaline cartilage is also a model in which we form bone. Most of the bones in your body are formed from a hyaline cartilage model. But we have the flat bones are formed from what we call a membranous. Has you have to have some sort of template. So you have this membrane that eventually became ossified. In most of the rest of the bones in your body, it started as hyaline cartilage, then got ossified and replaced by bone. So cartilages are also an important component of the skeletal system. So functions. So here's some of the functions that you can put in. See if you can make sense of them. Support. Does that make sense? Why is my femur so big? Where is my femur? You should already know kind of where the femur is because you know femoral region. That's your thigh. That is your thigh bone. That is the biggest bone because it's weight bearing. So it's there to support pretty much the rest of your weight. Protection. What type of things do they protect?
Soft tissue.
Yeah, like soft tissues or like organs like skull protects the brain. Your vertebra protect the spinal cord. So they're pretty much very definitely for protection. Now everything is protected by bone though. That's why like if I hit you in the stomach, you don't really have much protection there because there's no bone there protecting you in the stomach. But the rib cage protects the lungs, so it's protection. Now why do you think it's good for protection? What is it about the bones that make it good for protection?
It's rigid.
It's rigid and it's hard. So remember all the calcium that's in there? So it stores minerals like calcium and phosphate. So it's involved in calcium balance. If my calcium levels in my blood get too low, I start breaking down bone to get to it. 99.9% of your calcium is stored in, actually it's more like 99%, but it's close to 100%, but not quite, is found in bone. So if we need to get some more calcium, if we don't get enough from your diet, we're gonna go for the bone. I mentioned about the levers. So it allows me, like if I'm having my things like this, I can lift things a lot easier than if this was just one long thing. So acting as levers makes it easier to lift things. You don't have to generate as much force to lift things. So they have to act as levers. And they'll be involved in movement because the muscles are attached to the bones and it allows you to move along. So also yellow marrow, you see yellow marrow here. Anybody ever eat ossobuco?
Yes.
Okay. Yeah, that's what you're sucking out. Okay, so you're sucking out red marrow and yellow marrow. So the yellow, and it's yellow marrow is fat. So I'll show you kind of, it's in pretty much the center long. When we look at the long bones, I'll show you what the yellow marrow is. But the red bone marrow is where blood cells are formed. So all the blood cells, your red blood cells, your platelets, your white blood cells, they're all produced in your red bone marrow. Okay, so you have red marrow and yellow marrow. When you make broth, bone broth, when you cook down bones and make some broth, you're cooking down what's inside the bone. Then don't gross you out because everybody's made broth before, unless you're a vegan, and then you probably never did. But it has a lot of nutritional value when you use broth because there's a lot of stuff in that bone. Okay, so that's why dogs love it too. Okay. They like bones. Okay. All right. So classification of bones. Actually, I should have you. Actually, I'll do this. So we can classify bones first by the kind of type of bone it is. You got compact bone. Remember that bone model that we used, which you're not going to use again because we already did it. Remember that model you had to know about the lamella and the osteon? That was a model of compact bone. It's very dense. You see here, this is compact bone right here and right here. The trabecular bone or spongy bone is very spongy looking. It has a lot more air spaces, and those kind of the little spicules of bone are called trabecula, which means brace. So you have spongy bone and you have compact bone. When we look at different classifications of bone, they'll kind of tell you that this is compact bone with spongy bone in the middle, or this is mainly spongy bone. So that's where they're talking about what the difference between spongy bone and compact bone. So compact bone is just a lot more dense. Spongy bone is spongy. And spongy bone is like where we're going to find red bone marrow. Is where you're going to find the spongy bone, or in the spongy bone, the red bone marrow. So here, I'm going to just show you a various bone. And then I do that every time. It hits that every single time it pops. Okay. You guys will probably do that too. It's because you pop those things up with a thing. All right, so we can classify bones based on shape. Okay? So we can do